Prakash Sharma, Vijay 239, Vishal Dwivedi, Ashish Kumar, Ankush Porwal, Soham Patel, and Tushar. So 53 participants have joined. So okay. It's already 12:35. So good morning to and all present. Thanks for the invitation. So today I will be discussing about unions in C. Deepak,
சொல்லுங்க சார்.
ஏதாவது ப்ராப்ளம்னா just intimate me, okay?
ஷோர் சார்.
Slide is shared, right? பாரு full screenல போடுறோம், தெரியுதா பாரு, தெரியுதா?
தெரியுது சார்.
Okay, fine. Okay, right, good. So last class we have discussed about structures, right? So structures are the collection of data elements of different data types, right? So we have discussed about how to declare a structure, how to access the members of the structures, what's the difference between an array and the structures, and how to pass this structure members as an argument to a function, how to declare a pointer to a structure. So these are all the topics that we have discussed last session. So today I'm going to tell about the union concepts, which is very similar to structure. So just look at this, everything is very similar to structure. Only thing is that keyword, there we have used the struct keyword for creating the structure, whereas here we will use a keyword called union here. So union followed by user defined name. So this program just declared a roll number and a pointer, a name character pointer, and the variable declared is S1. S1 is the variable to access the members of the union. So there are two ways, just we have discussed structures. There are two ways to define. One is after declaring the structure, you can define a member here. Similarly, after declaring this union, you can have a variable here. S1 is a user defined variable name to access the members of the union. So in the main function, I use the same variable S1 to access the roll number and the name, just printing out using dot operators. Again, the same thing, dot operator is used to access the members of the union. So this is another way where I have a union as a separate structure, and in the main function I will be defining the instance to access the members of the union. So there are two ways. It's very similar to structures, and this is a program to differentiate structures and union. If we just look at this program, the left side program is program using structures. The right side one is a program that is created using union concepts. Tell me, what is the output of the both the programs? The structure program declared a of 10. So integer, if I use 4 bytes for integer, so 40 for integer, and double as 8. So 40 plus 8, totally it will print the size of the structure. It will print size as 48. Whereas the same thing I used in the second program also, but here it will not print 48. It will take which data type has the largest bytes. So out of this integer and double, so I have a of 10, so 40 bytes is reserved. Here double 8s, so the maximum bytes of the data is now int only, so it reserves only the highest data range, so 40 will be reserved. So whereas you can store integer as well as you can also store the double data bytes also. So that is the main difference between structure and union, only in terms of memory optimization. The memory is not been effectively utilized in structure, whereas in union the memory is optimized. And this is what the nested union, union that is declared within another union. I think the same example that I taken, structures concepts, the same thing I used here. this union person is there. That union has the name, age, and date of birth as the members of this person. And similarly, the outer union is student. The members are roll number and the marks. So to access the inner union members, I have declared a variable P here. So P can be used to access the inner union members. Whereas STU is the variable that can be used to access the outer union members. That means roll number, you want to access roll number and marks, you have to use this STU. Right. Pointer to an union. So this is the union. The union name is book. The members are what is the name of the book and how many number of pages this book contains. So the accessing is you have to use this arrow mark symbol to access these pointers. So this is a pointer to not a structure, it's a pointer to a union. The same example I have taken here. So union book star, this is the pointer variable to access the members of this union. And this malloc statement is used to allocate the memory blocks dynamically for this union. And this arrow keyword, bptr arrow of name, you can access the name of book. And bptr arrow mark of pages, you can initialize the value for name and pages. So this is pointer to a, so same thing, passing a union as an argument to a function, same, everything is same as like structures. Only difference is the memory allocation. So that's what about structures and unions. Next topic is I'm going to discuss about dynamic memory allocations. So you know what is a static kind of memory allocation and what is dynamic kind of memory allocations. So static memory allocation is just like the memory, the elements are already fixed, and those static allocations are compile time allocation. That means before the compilation process, you have to give how many number of variable to be declared, what is the size of the arrays and all. So everything has to be declared before the compilation process. But there are some scenario where this static allocation is not being used. There are some runtime applications are there where every time the size is not fixed. So sometimes if you can declare a array of 10, but you will be using only first 5. The remaining 5 space will be wasted. So sometimes you could define only 10 variable, 10, 10 array of 10 elements. But if you want to increase more than 10, that is not been defined. So at that time, there will be a segmentation fault. So you cannot able to shrink, enlarge, or you can shrink the arrays. So again, you have to come to the program code, source code. Again, you have to change the structure of the programs. So that is why what you can do in the sense. So these are all the limitations of static memory allocations. So before compilation process, I should know how many number of spaces required. So I have to tell to the program that these many number of spaces required. So dynamically, if it changes, no, there is no idea whether it is going to dynamically change or not. So what I am doing here, int a of 5 means I am declaring 5 elements of integer type. So totally I will have 5 into 4, 20 bytes. So initially I reserve only 20 bytes. So out of other, so suppose if you want to store more than 20 bytes, no, this is not applicable for this. Again, this is one way to have a dynamic way of initialization. Again, 10, 20, 30, you can use only 3, the space is 4, 4 close by, so 12 bytes can be reserved. So what I'm going here is I am int star p is equal to a. I'm passing the base address to this p. So p is a pointer variable, right? So where this pointer variable can be used to access the elements of the array. You can able to iterate through each and every elements of the array. But the problem is the array size is fixed. You cannot change. Every time you have to go to the program and change before doing compilation process. Right. So dynamic memory allocations, these are all the steps. So what I'll do in the sense, uh, I'll not define the size here. Whereas I'll have only the I will say how many number of inputs I'm going to use, how many number of inputs. That's it. So n is here, and there is a function called malloc statement. Malloc is used to dynamically create the memory blocks. So this is a syntax malloc of this. The argument is how many number of bytes you want to reserve, right? So so if I declare here integer star p, it's a pointer variable. It's a pointer variable, just like we have discussed here. Pointer variable. If I'm giving the starting address of this array, this pointer where can be used to iterate each and every element of the array. Similarly, I will use the same concept. Int star p is a pointer variable to access the members. So I used p is equal to malloc of here. What I use 4 multiply with n. So I'm getting an n here. So n is a dynamic. So during runtime only we will be providing the n value. So that n value I'm taking up here. So suppose if I give the value of n as 10, 4 into 10, so 40. So 40 bytes will be reserved for this. Again, suppose if there is a need that I want to go beyond 40, I would reserve for 60 or 70. What you could see, you can run the program, then you can change only the n value, so that this n value comes here and automatically this number of bytes will be allocated. So it is not during compilation process. After the compilation, that is during the execution of the program, we will providing you the number, and depending on that particular runtime value, automatically this memory blocks gets updated. So this is the malloc is used for dynamic way of memory allocation. And now this I have hard coded as 4 here. Instead of 4, some compiler will have 2 bytes. Some compiler will have 8 bytes. So instead of that, I could use here, instead of 4, I use size of integer. So size of integer, it returns the number of bytes for integer. Some may take 2, some compiler may take 4 bytes. So this is this syntax of this malloc. So malloc of size of int multiplied with n. Right. Now this diagram you could see here. This is the memory organization. The first one is a stack area. What is stack area? If I declare int a is equal to 10, all the local variables will be stored in the stack. So stack is a memory block. There is one more area called heap area. This heap area. Then followed by, so this section is called as a data section, and this part is called as a code segment. So a memory block will have both the code part as well as a data segmentation part, right? So when you use an malloc, this memory blocks will be reserved only in a heap area. So this malloc will be used only this area, not the stack. So stack will be used for local variables only, returning some numbers, local variables only. Whereas malloc can be used only for this heap area. That is only different. So here I use here. The problem is that malloc, the return type of malloc is actually a void pointer. It is a void pointer. So you know what is a void pointer? Example, if I take int star p, if I use float star q, this p is a pointer of integer type. Am I correct? If you use float star q, q is a pointer variable which can store only float variable. Am I correct? This will store only integer variable. Suppose if I use void pointer, this pointer can be used to store any value because it has been void. So any value can be stored for these pointers. So what I could do here, if you declare a void pointer here, the address of this p and this address of q can be used to store this one. So void can store both integer as well as the void can be used to store this float also. So the thing is that if I use here straight away, if I use malloc, it will return a void pointer. So previously I used only this one malloc statement size, but the problem is that it will not return an integer. It's a void pointer. So what I have to do in this sense, I have to do a typecasting here. So if you use an integer pointer, I have to typecast into int star, malloc of size of int star. So this is an example to allocate the memory block of memory using malloc. It's a dynamic way of allocation. So similar to malloc, these are all the different functions that can be used. Malloc is only a single block of memory can be allocated, whereas calloc can be used for arrays of memory. And realloc, suppose if in malloc, if you want to just change the size, so realloc can be used to extend the amount of space that is already been reserved. So in malloc, if it has 40 bytes, realloc, what you can do in the sense, you can just extend the amount of space. And free functions is used to deallocate the memory. Whenever there is a program has used all the memory space, and if it is no longer, it is not going to be valid, that time you can use a free pointer to delete all the resources. So that is so these are all the 4 different functions used for memory management functions in Z. We use only malloc. Today I'm going to explain about malloc. I think we are running out of time. Only five more minutes, I guess. Yes. So this is the syntax of this is the syntax of malloc. I think we already discussed. And this is a small program to tell you the concepts of mallocs. So what I'm doing here is a pointer I declared here. I'm getting total number of value here, and based on this value, I'm reserving using malloc. Same thing. Int star is the typecasting malloc of size of int into n. So if I declare n as 10, now 40 bytes will be reserved for this. So 40 blocks, 40 bytes of blocks will be reserved. And if p not equal to null means it will just print as the memory block is allocated, else it is not allocated. That's it. And this is the program to get an input for these memory blocks and to print what are all the values stored in those blocks. Again, same example I taken. I am allocating the memory block of the given number. I am checking if p not equal to ln allocated, otherwise not allocated. And next what I am doing, I'm iterating from I equal to 0 up to n, because if I use n is equal to 5, so total size is equal to 4 into 5, 20 bytes will be reserved. And now I'm doing here for I equal to 0 to 5. I'm iterating, I'm getting a value for each and everything. So p is the starting, that means what the malloc will return is the malloc will return the starting address of the blocks. So that means 20 bytes means it will return the starting address of that particular block. So here p is a starting address plus I plus 0. So it will get the value for the starting address. Then each and every time it will get for I equal to 0, 1, 2, 3, go up to 4. If I declare n as 5, we'll get up to 5 elements. So this is to get a value, and next for loop is for printing the value. That means star, you know what is star, right? Star is used to access the value at that particular block. So initially the starting address is the particular address will be there. So plus 0 means it will start starting address. The value at that particular address will be taken. Again it will go here, I is equal to 1. Now that p plus 1. So initially p is equal to 4000 address. So next it will go to integer means it will go to 4002. It will print what is the value at 4002. Again I value increases. Next value will be 4004. It will take the value at 4004. So this will keeps on continuing till it retrieves all the values of the blocks. That's it. So this is program malloc statements. So any doubts, you can just raise your hands, and those who came late, you can send me a message, or you can raise your hands for attendance. If you have any doubts, you can ask. Vishal TVD. Vishal,
Yes, sir.
any doubts?
No, sir. Actually, I came late, sir.
I already noted that Vishal told me I noted.
Thank you, sir.
Path Street, 228. Srishesh Kapoor. It's noted. Deepak? So no doubts. I assume that there's no doubts there. So thank you for your participation. I'll just close the meeting now.